Okay.
Yeah.
So then data modeling, then data warehousing. So I'll merge these concepts, all of this in ETL only. Okay. What's data warehousing and all, and then uh, what do we have? Database management system, that should be fine. Then we have cloud. Uh, Cloud, like AWS or
Mm.
something. We learn that. What's data integration is from different sources you're bringing data and then trying to load that into your data model, something like that. So again, a similar kind of topic. When we'll see an example, we'll cover that as well.
Okay.
Data quality and management. So once this is the last topic, I think, like once we have uh, your data loaded into your table, what quality checks do you put? So do you remember that?
I about to say that. Yeah.
Yeah,
Great
yeah,
expectations.
great
Remember.
expectations. Yes, yes. So the great expectation was for that great
Yeah.
data quality. Because whatever you load in your table, that data should make sense. It
Mm.
should not be like you are loading anything which, suppose a company made 100K in sales in reality, but the data what you have loaded in table is not correct. It is showing like maybe 50% less than that or maybe more than that. So it should not, that does not make sense, because based on our data only, the companies derive their values or take business decisions. So so that's not I mean good, that if the quality is not
Yes.
data. Yeah. Then scripting language, that should be fine. Do you know Unix or so?
Uh, no, I don't know those commands. Like I hardly know push command, pull command, these things except nothing else.
No, that is Git. This is Unix. Unix is like copy command,
Yeah,
move,
a
cd.
little answer. Yes, that
Yeah,
CP make directory mkdir.
yeah,
Probably
yeah.
very little.
So I means I used to do in shell scripting previously, but sometimes this is not needed. So why it is needed? Like if you are connecting AWS from your command line, okay,
CLI.
yeah. So then the some basic scripting knowledge would be needed, that CD and copy and make directory, something like that.
Yeah,
So okay. Then there is Airflow, which is like scheduling tool, how your jobs will run and something like that.
the exact.
And yeah, that you know. And then there is versioning control like Git and all. So Git will try to explore uh, once our code is like whenever I teach some SQL and Python and we have developed a code or something, or when we'll do a project at the end, how
Mm.
to load data for that. In that case, we can cover Git.
Yeah.
Data governance and streaming should be fine. Like there are two kinds of ETLs we do usually. First is like batch one.
Yeah.
Batch means like you load every day or every month or every week or something, like, depending upon your project
Yes,
or
the
system.
PHM. Mm-hmm.
Yeah. Then there is like as soon as event happen, it should go into database.
Right.
So that's streaming. So right? When you withdraw money,
Yes. Yes.
you get an instant message. So that kind of events are streaming ones. Sometimes, like even now these days, retail companies are also doing that. As soon as any like in Amazon, you shop something, within that second, the record should go into database, something like that.
Yes.
So that streaming we won't cover. Even I have not worked on the streaming use cases as well.
Okay.
Okay.
Mhm.
Batch, I think, should be fine. Okay. So we'll start with then SQL today,
Okay.
uh, and then we'll see. So what do I have? I have one more to have, and then the viewer. Hold on. Did you ever like you know basic SQL, right?
Yes. Yes.
Anyways, I'll start from with scratch. So just let me see what tables I have at my end. And then this is this schema, properly tables is nothing. Just give me a second, okay? I had created, yes, I have this. So, okay, before we uh, start, like, I'll tell you some background, and this is data warehousing also, okay?
Okay.
So, there are two kinds of like uh, data warehousing techniques again, or what do we call like usually you will see two kinds of uh, projects or consider data warehousing techniques. Okay, so
Okay.
have you heard of OLAP and OLTP?
Yes. A lot of times, in fact.
But
But
do you
I
know
don't know
that?
this. Yeah, I don't know what it is. I just heard it a
Yeah.
lot of times during the
Yes,
interviews.
yes. So we'll start from that because that will make you some like bring some clarity on why we have these kind of things.
Okay.
So suppose like what is OLTP is online transaction processing, something like that. And then there is OLAP. Both have different use cases. Okay. So OLAP is usually used for reporting. Now you write it at your end. Okay.
Yeah, writing it.
Uh, OLAP is used for reporting, and OLTP is like uh, in OLAP, right? Analytical reporting, something like that. And OLTP is like, oh, whatever transactions happens, you just process the data for temporary amount of time. In OLTP, your insert should be faster, and
Okay.
I'll talk the examples why it is in that way. And OLAP is like your select should be faster because you're doing reporting, right?
Yes.
So suppose if I have connected Tableau or Power BI or any kind of reporting tool, your data fetch should be fastest. Okay.
Okay. Okay.
Uh, and in your OLTP, your insertion of the data should be fastest. So what happens is, suppose that banking example, you withdraw money of and forget it, like if you are doing streaming or batch, maybe my bank is sending message tomorrow
Okay.
because not using streaming. That's unlikely though, but just consider for this example.
Okay.
So what happens is, first the data goes in OLTP systems, because that's where your insert for initially your data is inserted into your OLTP systems. Okay. Now these OLTP systems were like Oracle or MySQL or something like that. They were designed in a way that your inserts were faster. Now, there's one more. Let me see and Google. OLAP, OLTP, and if there is image. Uh, yes, so this image I'll show you where it is from. Forms to enter picture in picture. Okay, I can share my screen. Where do we get that option? Okay, then this. See my screen.
Yes.
So you see this image, okay?
Mm-hmm.
So what happens is, suppose before this also, where does data come into your OLTP database or anything is like uh, would be an application before which actually gives some data. Now, when I mean application, it depends on like if it is an Amazon or an ATM can also be an application in this case when I'm trying to explain. So that ATM just sends us data and everything just gets inserted into OLTP. Okay. Now OLTP cannot store huge amount of data. What happens is at a certain point of time that if that Oracle or that it cannot they were not designed to handle huge data, and that's where data warehousing came, like hey, and there is no reporting done on maybe OLTP databases as well. Okay, as I said, main aim of that is like just dump the data for temporary basis for now, and then we'll dump it afterwards in a data warehouse, which is like a huge database. Like these days it is earlier it used to be like Teradata or something like that. Now it is Redshift, and BigQuery and something like that. Now they are designed to handle huge amount of data.
So are you
Also,
saying OLTP is designed to handle huge amount of data? You're
hello,
breaking, Aditya.
I am breaking. I am in network though. Is it good now?
Yeah, now it is better.
Okay, maybe some Wi-Fi issues. So if you see the architecture of OLTP also, they it is different than OLAP because they do serve a different kind of purpose altogether. So inserts needs to be faster in OLTP, and then once the data is collected, maybe after 1 month, every month it is dumped into a data warehouse something, and data warehousing would have like your historical data, petabytes of data, terabytes of data, and then on data warehouse your reporting is done.
Oh,
So data warehouses have consider data warehouses as OLAP.
okay.
Okay. And whenever you're fetching data, your insert needs to be faster and all. Those are OLTP. Okay. Why now? You will say, why can't we just directly dump data into warehouse only? Now this was a very old kind of architecture. The world is evolving now. Uh, Usually we do not have like these days OLTP. These days OLTPs can be like S3 bucket or something like that. We have moved out from this uh, you know um, we are moving out from similar kind of architecture which I am trying to show you.
Okay.
Right now they call it as, um, what do we call it? Data lake. Okay. And
Right.
then you must have heard Delta Lake as well.
Yes.
Uh, so, so Delta Lake is nothing but, your collection of delta tables and all those kind of stuff. Data lake is like where S3 or data is being dumped or something, like maybe it can be raw as well, something like that. So we are moving out of these typical architecture these days, but initially, like, it is good to know that what is OLTP and OLAP. Now, any questions on this?
No. So
You get
OLTP database, yes, OLTP database is a generic term for local servers like or local some database, traditional databases like Teradata, SQL Server. Can I
No,
say this?
Teradata was a warehouse, data warehouse. It was
Okay.
designed for. So Oracle and all MySQL, they were like considered as OLTP databases. Okay.
Okay. Okay.
Now, one more important thing, so because you are dumping data into OLTP, your data model for that would be different.
Okay. Okay.
And when you are putting data into your data warehouse, your data model, or maybe the whatever is your presentation layer from which you will fetch your data, that can be different. Now I'll tell you why. What was the use case in OLAP was like this: your select should be faster. So select means like, when will your select would be fastest is there is no join or something in
Right.
your query. Join takes a lot of time, and consider you are having petabytes of data in your data warehouse.
Right.
So if you try to join one table to the another, your select will become slow, right?
Yes.
So my huh,
And that's when we use views, right?
no. So I'll come to that as well.
Okay.
So what I'll try to do is, I'll try to create a table in such a way that all the columns lies in a same table only. Now I'll have my job designed in such a way that I'll do the joining initially, but I'll be in joining, I'll fetch out some data and put that in a one big table which would have all the columns. Okay. Now that table is used in reporting, because now in that table you have all the columns and everything info. Okay. Now I'll show you some tables as well, to
And
understand this, what I said.
that's what we call it as target table, where
Target table or presentation layer, or something like that. So which is connected to your reporting system, or after that, or maybe only data science models, or any kind of visualization tool is connected.
okay. Okay.
Okay.
Understood.
Now in that table, the aim is that you should have everything to avoid joins. That is the ideal aim. And that's where your selects become faster, because everything is available in a single table.
Okay.
You don't have to join.
Right.
But now this was OLAP. Now it served its purpose, like the select would be faster, and that's why the data model is a bit different in OLAP. Now in OLTP, your aim is your insert should be faster. So suppose if you have a one big table built in OLTP, where five columns would be your product information, and five columns would be your transaction information or something like that.
Hmm.
Now, if you keep everything in one table, it would become very difficult to manage that table when you are trying to insert data. Now, I'll tell you. Suppose product information is coming from your application is sending, like, suppose a person has purchased some has done some shopping. Okay. and then might have purchased from Amazon, for an example. So he might have purchased 10 different products, and then there would be some amount which he has paid, and then he might have used some card to pay or something, or UPI or whatever. Uh, so all this information is collected from that app. Okay. Now, when you will try to insert data, and suppose in your OLTP you just have one table. Okay. So how would you insert that data? Like now, because you also want to know what is your who is your customer, who is your customer. Uh,
Okay.
so suppose if you are putting customer information in that same table, but the other tables would be like the other columns would be null for that, because right now you're just putting customer information into that. Uh, or hold on, what happens that if you just get one record which tells you like what shopping has been done and everything, you put as it is into the system. What
Right.
happens is tomorrow, if the there are use cases like what kind of age group is doing some shopping or something like that. Okay. Now age of that customer would change tomorrow.
Yes.
Now, would you update your the only record which you have got from your app, and as is you have inserted into an OLTP? Are you getting what I'm speaking?
Yes. So you're saying, let's say there are details of a customer who has shopped some on a certain day, which includes
Uh,
his age as well. In the
uh,
future, we are trying to fetch the age of the customer, which would change apparently over the time.
yes, yes. So that is why a segregation is needed.
But
I'll keep I'll keep my customer information separate. I'll keep my product information separate initially. What kind of products I am selling, that I need to know. Prices of that product also changes. So I do not update my that all of these records every time. Okay.
right,
What I do is initially I'll keep just and that's where the concept of IDs and all came into picture. Okay. So suppose my aim is to insert data faster in OLTP. What I'll have is I'll have a customer table separate,
mm,
where I'll only enter which all customers have registered on my Amazon app. Okay. And I'll just store that information in that table. Now, second is what kind of product I am selling. So a product table is separated out. Now, tomorrow, if there is a pricing change in that product, I'll just update that product. Okay.
that
And
product table. Mm,
yeah, a product table. And how does then get it related? So I'll also have a transaction table also. Okay. And in that transaction table, I'll just mention customer ID, product ID, and whatever order amount and all, amount column and all would be there in the transaction cell. What amount I've spent and purchased, and how much discount I've got, something like that. Now, this ID of customer and product, I link it with the customer table and product table. Okay.
right,
And if the pricing is changed, that would be tracked in your product table itself. So these IDs help to generate which uh, how these two can be linked. Okay. And I'll change the age of the customer and all every time or something like that. And as soon as you join on these IDs, that would get reflected in your results. So that is why a segregation is needed in OLTP as well. And the main aim of that is in you insert your data in the fastest way possible, and also it should be in a maintainable way also. That's also a main motive also. If your designing is horrible,
more
then it
clarified manner.
a clarity is needed. Like if your designing of data model is horrible, then you will suffer with the data quality, because like age is changing and you're not updating. It becomes very harder to update all of the records and keep track of. Now I'm just talking about age. In real life there are 15 different kinds of, or 20, or sometimes 100 different kinds of these kind of issues, like age, and then address. Address is also one of them. Then maybe, and this is just customer related, then there is product related also. What if in one store I was selling 100 products. Now next time I am selling 50 products only. So all these scenarios get changed. That is why a segregated table is created. Okay, initially. Now are there segregated tables in data warehouse as well? Yes, there are. Uh, in OLAP also it is there. But at the end, you have these segregated tables. You create one big table at the end in OLAP, so
Yeah.
that I do not have to join and the select become faster.
It
Okay.
is vice versa for OLTP.
Vice versa for OL. No, what I was trying to say was OLAP and OLTP both would have segregated tables. But
And both will have a consolidated tables, but uh, whereas in OLAP we will try to fetch the information to put the select faster, to fetch the data faster. We will use a consolidated table, probably a
consolidated
target table.
table, but the consolidated table won't be there in OLTP
Oh,
because it cannot handle huge data.
okay.
Okay. In your consolidated table you should have history as well, right? Suppose my use case is I want to see what is my trend, but OLTP does not handle 10 years of data. So so that becomes difficult. So that is why, OLAP is better. OLAP databases are better because they are designed in such a way that they handle huge data. Okay. But what I was trying to say, that segregated tables would be present in data warehouse as well and OLTP as well, just because you have to maintain data correctly also.
Yeah,
But the main aim of OLTP is like, insert should be of fastest. Okay.
understood.
Um, so that's OLAP and OLTP. Now, when we'll go further and discuss other topics, I'll try to link uh, why it is done in this way. There's one more concept in data world is normalization. Okay. Now, that is somewhat needed. Now I'll tell you why. Um,
And one question, Aditya, what are these called? OLAP, OLTP? What, under what concept does these come? And for OLTP, it is not just inserting, right? It is also updating, for even to update it faster. Can I say that? There are
uh,
data tables.
yeah, insert, update, or whatever. It depends on your loading strategies, how you are designing. Maybe every time you are doing truncate and load,
Hmm.
then then there is no update. But if you have like, you are updating the previous records or something like that, then you will have that. These are parts of data management systems. That's what they are saying. Okay. So
They,
data management is divided into two different parts, is like OLAP and OLTP. Okay.
okay,
So again, you see these are OLTP thing, and at the end it is dumped into a warehouse. Okay.
okay.
Data warehouse.
Yes.
And what
As you
else?
said, it is like S3 or
Yeah, now these days what has happened is that the usage of Oracle and all. So do you remember that patient planned parenthood one? It had they had MySQL, I think, right?
yes, yes, SQL Server. Yes.
And then you were putting it into Redshift, right, at the end.
Yes, through RDS, DMS.
So now you can relate that example.
Yep. Yep.
That MySQL was your OLTP,
Okay. Okay.
and then you are dumping data into your Redshift for reporting purposes. That's where I think Power BI and all was
Yep.
connected to warehouse. Okay.
Yep.
Now, does that mean that you cannot do reporting on OLTP? Yes, you can do it. Nobody is stopping you, but they were not designed for that purpose.
Yeah. The main motto is not.
Yeah, yeah, yeah.
Okay. Understood.
Why it is not ignoring this? Ah, okay. So, no, yeah, I was showing you normalization. So again, DBMS is like, okay, so there was one thing like database management in our roadmap.
Mm.
So this is what I'm, all these concepts would come under database management. Okay.
Okay.
Uh, but it I think that initially, if I tell you that, it would set a good base for you to understand why things were in this way.
Okay.
Um, so yes, this is the example which I was telling you. So the example which I told you, like if you what if you don't segregate your table, it is related to that. So
Okay.
suppose this record, you're all just putting it into one table, okay?
Okay.
Like employee department, everything. Now, as I said, there would be difficulty. Suppose if I am changing, my department every now and then, or something like that, or my location is changing. So it becomes very harder to manage those tables because things might change from time to time. So it is better to have segregated tables. Now this segregation is actually nothing but normalization in this term. Okay. Now
Okay.
there are two three kinds of normalization. Now you see that employee information is separated, department information is separated, employee skills is separated. Okay. Now there are two, three kinds of normalization. Is like first normalization, second normalization, 3NF, 4NF. What happens is in for your first NF, now I won't go too much into detail because you would get confused.
Okay.
Um First normalization is like maybe you are breaking the one table into two tables or something. Okay. And then maybe in second NF, you're breaking those two tables into maybe four tables or something again.
Okay.
And then your what do we call third normalization would again break those six tables or 10 tables into
Okay.
furthermore. Okay, so
Okay.
that the segregation is much more clear. Now
Right.
initially this is like one NF or some this is like the whole dump, not this one. Now, if I just segregate employee and
Are you seeing anything? I only see normalization definition.
okay, you're not seeing. Okay, hold on. Stop presenting.
I think you are sharing only window.
Yeah, maybe. Uh, I was sharing tab,
Okay.
not even a window. So, what is this? And let me know if you get confused. Okay.
Okay.
I'll stop this. Now, do you see normalization? This thing. This is the example which I was talking.
Geeks for geeks. Yeah.
Yeah. Okay. So as I said, this is just one record into one table. Now further, this was segregated, and that segregation, in other words, is normalization in data management system. Okay.
Okay. Okay.
Uh, Now there are different types of that. As I said, 1NF, 2NF, 3NF. Okay. Then BCNF, 4NF, 5. If you increase your normalization from 1NF to BCNF, you would increase your segregation more, in other words.
Okay.
Correct?
Right.
Now, suppose if you have more segregation, that means you have specific information um, for a table. Okay, like customer is segregated. So your OLTP is more normalized. When I say more normalized, it maybe it can be 3NF or BCNF or something like that. Okay, usually I have seen till 3NF and all. Okay, now
Okay.
why I am not going into too much of details, but if you have your if your insert needs to be faster, your specific information would be inserted in a faster way because you have a specific table for that. What if you keep just one table, that becomes difficult to manage, so that is also not option. Okay, so in 3NF you would have more segregations. That means more normalization in your OLTP system. Okay,
Right.
now if
I
you
think the example which you have shown, I'm
Mhm,
thinking so. It is
mhm.
3NF, the example which you have shown.
This one, not just because this is three tables,
No,
it
no, no.
depends.
Not because
There,
but
huh.
employee table was further segregated, so that is why I'm assuming it so.
Yeah, so there are rules of what comes in 1NF. So actually what happens is that there are certain rules that if a relation is in a first normal form, if attribute in that relation is single valued attribute. Now this is always sometimes confusing, like what does that actually means is like, I'll show you one of the examples, like is uh, now consider in this table, is employee in a record dependent on department location. Actually department location is uh, more aligned to department column, right?
Yes.
So I'll do is I'll segregate these two tables first, and I'll put an department ID maybe into employee table so that both are connected.
Yes. Yes.
Okay, so that is somewhat like 1NF or 2NF what I just told. Okay, so
Right.
it is, there are rules. Okay, 1NF, I'll tell you, in one row you should have just one value. Now you see this employee skills.
Okay.
Now employee skills is like for comma and all it becomes harder for then reporting purposes in OLAP and all. Okay,
Right.
uh, so because I don't, if I keep this in this way, if I do how many Python employees skills do I have, I won't be able to calculate that.
Right.
So first NF is like every row should have a single value, something like that, in other words.
Okay.
Okay, in simplest words. 2NF is like what I've just told previously, that does department actually depend on department location actually depend on employee table?
No.
No, it depends on an what department you have.
Yes.
So so you will segregate these kind of, because there is no direct relationship between that. It is like intermediate relationship is what we call actually. um, um, Not direct relate, it is not directly related, right? Suppose if it was age of employee, then it is directly related to that employee, right?
Yes.
But so that can be in one table. Okay,
Hmm. Hmm.
this is a different kind of information, and which is related to employee in a way but not directly related. Okay, so we'll segregate these two tables. Now if you do furthermore segregations, like you will have a lot of tables at the end, right? Now what happens in OLAP is you cannot have too many tables, right?
Yep.
Because your join would. So what does then your OLAP has? It has denormalized tables at the end. At the end, okay.
Okay.
Initially you might have, but whatever table I am doing reporting upon, that needs to be denormalized. Okay.
Okay.
So the OLAP aim is also to have denormalized table so that its aim of select faster becomes true. Okay.
Okay.
And no join should be there in ideally no join should be there in OLAP. Okay,
OLAP.
that's ideal world. Yes. But in OLTP, your joins, if you try to do reporting, you would increase your joins and your reporting would be slowest. Because in OLTP, your aim is to insert data faster, not do reporting. Okay.
Right. So you're saying
So
in LTP the joins could increase.
in OLTP, the joins, yes, because you have segregated tables for each of them.
Mm, mm, mm.
So at the end, if I have to collect, if I now this table I'll anyways create in OLAP, but not in this way, like recruitment,
Yes.
comma, payroll, it won't be there. So
Yes.
with some cleaning and all, I would create, but I am first maintaining that data in a proper way. If something is changing, these segregated tables are tracking that information correctly.
Right.
Okay, and then only I am developing a denormalized table for reporting so that it should have correct data. Okay.
Okay. Okay. So normalization is something used for OLAP and it is basically
No, no, no.
categorizing the data.
Other way, normalization is used for OLTP. Normalization is increasing,
Sorry,
increasing.
my bad. My bad. OLTP. Yes. Yes.
Yes, increasing your segregation is normalization.
Yep. Yep.
Okay, and decreasing your segregation is denormalization.
Yeah. Which is used
Okay.
for OLAP.
Any questions on this?
No, no.
Will you ever
Clear.
forget this?
Clear. Clear.
Okay, keep reading like 1 or 2 times and you will get that for
Oh,
lifetime. Uh, Now there are features like why do we need normalization? As I said, data quality issues and data consistency and all this simplification by data management, improve database design, avoid update anomalies. Anomalies is like bad records. Bad records in the sense, like as I said, the age is changing, but you're not. If you it becomes difficult to manage, if you're not
I think I lost you, Aditya.
wrong in, but if you have not maintained that age column correctly, your
Hmm.
decision would go wrong. You would target older customers than targeting young customers, something like that.
Yep.
So this was just one example. Now, as I said, in real life there would be many different kinds of use cases,
Right.
and then some standardization. Okay. Uh,
And of course, yeah, in generic terms also segregating something, categorizing something, arranging
the,
the order will
yeah.
avoid any anomalies,
Yes.
any
Yes.
redundancies, right?
Yes. I always give one example like suppose I have an empty wardrobe
Okay.
and I give you a dump of clothes which has jeans, t-shirts, everything, your um, whatever you wear, your innerwears and everything.
Yep. Yep.
Now, if I give you a mix of that, it becomes difficult
Mhm.
sometimes to suppose I have give you whole room full of or house full of this dump clothes. It, it will become difficult for you to count how many jeans I have
Yes.
and then plan your budget accordingly. What should you buy or something like that? What if I separate now when you will store your data, you store jeans in your one wardrobe, Suppose now we don't do that, but
Hmm.
suppose you're a rich person and
Hmm.
you have jeans in one wardrobe, t-shirts in one wardrobe, and so that becomes easy.
Right.
Inside wardrobe also we do these kind of things like jeans separated, t-shirt
Yes.
separated, everything. So it becomes easy for me also to access data next time. But and maintain, basically the aim for normalization is to maintain data in a correct way. And if you do not maintain data in correct way, your decisions would go wrong when you do reporting. That happens. Okay.
Okay. Okay. Got it. Got it.
This relates to my first point. When I just started, your data should make sense.
Right.
When your data would make sense is you if you maintain it correctly, if you have designed the data model correctly.
Hmm.
Okay. If I have not done normalization, then I would have all these kind of junks
Yeah, but
present.
the wardrobe example
Huh.
is, I mean, if you put all the clothes together, it's also difficult to fetch the data from it, right? I mean, to select and fetch the data. I mean, it is
So,
not.
huh. So wardrobe example, maybe limit that to OLTP. Okay.
Yeah. Yeah.
Now, what happens is for reporting, I'll try to link that example as well. In that case, you won't do reporting. Okay. Uh, what happens is you will wear those clothes out.
Hmm.
So you will have easy. Suppose there's one more wardrobe who is for you, and it has just one row, and in that row now now someone is putting like you are a very super big rich billionaire.
Hmm.
Okay. Now you don't go to each and every wardrobe just to pick out jeans and all. You just go to that wardrobe where someone has arranged you your
Right.
clothes in the sense one row would have jeans, t-shirts, tie, shoes, everything.
Yeah.
Now you would, what would be easier? Would be easier like to go to each and every wardrobe and pick out what you need, or
Hmm.
someone has done
The
that
first
for you?
one. Yeah. Yeah. Somebody already
Yes.
organized it in the single
Yes.
wardrobe,
Yes.
named it.
Yes. So you are not joining because that is already joined and
Yeah.
someone has already given you what to wear. Now
Yeah.
that is
The bigger
OL.
wardrobe to put all those,
Yes, yes.
which is a
So that is reporting you can consider.
good
Okay.
one.
Yeah. Uh, so you have understood normalization, you have understood OLAP, OLTP. What else? Mm, now I think let's see some example of OLTP databases. So I'll just show uh, OLTP data modeling. So these are the real life examples. Like this is, I think, insurance companies or something like that. Okay.
Okay.
Now this is persons, beneficiary role, policies table, all segregated tables. Okay. And it says again normalization and OLTP data modeling. Okay. Whereas in OLAP, you would have segregated tables, but at the end, you would also have a denormalized table.
Yeah.
If you see in this example, you do not have a denormalized table because the aim is not for reporting.
Right.
Okay.
Right. Right. Instead
Uh,
of calling it as a consolidated, I would rather call it as denormalized table.
yes. Yes. Now, one more topic I would like to cover is types of data model also. Now, we were till now talking about data management. Okay.
Okay.
I would like to cover types of data model. So I'll just show you there are many ways of doing data modeling. Okay. One of them is dimensional modeling. Now, what I'm showing you, which is widely used. Okay. Now, what I'm showing you is dimensional modeling. and its type. So, have you heard of this Snowflake and star schema?
Yes.
Yes.
Yes. Yes.
So,
We did
mm,
that in that project.
okay. I think we had discussed that previously also, but anyway, so I'll tell you these things
Mhm.
as well.
I
So
only know
now,
star
mhm,
schema. I don't know what is the difference of snowflake schema. I don't know what is snowflake schema. I only know star schema.
okay, there's hardly any difference. I'll just tell you in a minute, in a
Okay.
second. So this is a like a star schema. It also says that this is a star schema. Okay,
Yeah.
you have one fact table, multiple dimension table. Now, does that mean that you will always have one fact table?
Uh,
Not necessarily, but ideally, yes. We for depends on your use case. What is your use case? If your use case is OLAP kind of, then ideally one table is should be enough. Now consider this. Uh, okay. By the way, here there is no here. Consider these are just normalized tables. Okay. I
right.
don't see a denormalized. Why? I'll tell you as well. Suppose I want to do reporting on fact table, but it has product ID. Where is product name? I cannot see how many products were bought in this month,
Hmm.
like that. So I'll have to join this product ID with this.
Right.
Now, do I need a join in my OLAP? No. So on top of this data model, there would be one denormalized table, which would have actually joined my vendor to vendor, product to product, and what else?
This is
There,
OLTP example.
huh? Yes. But what I was trying to tell you is there are forget about now OLTP and OLAP. Now we are talking about data modeling. Now it depends on your use case and what you have been told to do, like design OLTP or OLAP. Then these things might come into picture. Uh, but initially what I said is also remember that you would have segregations in OLTP and OLAP as well, but in OLAP you would also have a denormalized table extra, which is mostly used. Okay,
Okay.
so that segregation can be in OLAP and OLTP, and that segregation I am talking about here is like how do you data model your stuff. There are two kinds of data model. There is star schema and there is snowflake schema. This is a star schema. What if tomorrow I have one more table related to product only?
Okay.
Okay, so suppose there are two dimensions for my product. One, I just put like product category into this table, and
Hmm.
then the second table actually has product category and the product name also.
Okay.
So that once you have a further extension to all of your dimension table, that becomes your snowflake. Okay, but if you just have like one fact table and multiple dimension table, that is your star schema.
Okay. Can you say about snowflake schema again?
Snowflake schema, yes. So I'll tell you one more thing. Now consider this example. You see this image?
Yes.
This is just one fact table. This is just star schema is what I'm trying to tell you. Okay.
Right.
But if you further split this dimension into multiple dimensions again,
Okay.
like this is one fact table, and now you have one dimension which is furthermore splitted into four dimension, that becomes your snowflake.
Okay. So
Now,
even in this case of snowflake schema also, it is not multiple fact tables. It is still a single fact table.
now that depends on your use case. Suppose transaction is one of like consider that Amazon app example. Okay,
Okay.
um, or hold on, the Planned Parenthood one. Okay, so
Right.
we used to have multiple fact tables in that data model. It depends on your use case. Okay, I this is just ideal world with which is shown in the diagram.
Okay.
Suppose your company is doing transaction, like people were purchasing, um, like connecting with doctors and Planned Parenthood services. Now you would have a transaction table for that. You would also have a transaction table for lab reports,
Right.
right? Like what type of lab report, lab testing was done, and something like that, and then connected to lab dimensions, like what type of products in that case would be, what type of lab reports you are conducting at your end. Those becomes your products.
Okay.
Okay. So you would have dim product where you have listed all kinds of tests, but there would be a separate table for lab transactions as well, like which person has booked which type of uh, lab test, yeah, lab test. And then other was, other fact table would be which type of table, like who is taking a doctor's appointment or something like that. Now you, in your real life, you would have multiple services being provided. You just do not have one service to be provided. Okay. So in that case, you might have multiple fact tables as well. Now these multiple fact tables might be joined with all of the dimensions as well.
Right.
Okay.
Understood.
um,
Can I say it this way?
mhm,
Let's say, Aditya, consider the star schema only. If
mhm.
any of the dimension table has a further table, another dimension, then
Yes,
that can be considered as snowflake,
yes,
even
simple
one
as that.
dimension. Okay.
Yes, even one. Now I'll tell you why, in which scenario we would need Snowflake sometimes. And there is no one is stopping you to just limit to star or Snowflake. It is just from a use case point of view. What is your use case?
Okay.
If my use case is not, so let me tell you in first in that why we would go in Snowflake. And the example which I always give is, uh, your address. Okay.
Okay.
Now you have a country, you have a state,
Hmm.
and then you have cities into that, and you have districts into that.
Yes,
Now
that's true.
you can create n number of tables.
Yes.
Like a country
Mm.
table, a dim country can be there. Now it is connected to like dim country states.
Right.
Okay. Then it would be connected to dim country states city,
Mm.
something like that.
Mm. But
So I
as
can keep on increasing as per my need.
right, but I am assuming this. Okay. In your experience, I think at least you would have seen more snowflake schemas than star schemas. Is that right?
Hello.
Yeah, Aditya, can you hear me?
Yes. Now.
Okay. Okay. I was saying, I mean, in data engineering space, I think so. We see more snowflake schemas than star schemas.
Yeah. So I was coming to that point. It really depends on your use case. Now, with my example, okay,
Hmm.
um, is there like I can store the address with limited to my country information only, because I do not have a use case where I'll see something like which country is giving me, look, which city is giving me more profit. If my management does not want this kind of information, I will not store data at like city or country level. Did you get that?
Makes sense. Yes,
Yes.
but I was generally referring. What do you, in so far in your experience, which did you see more?
I have seen both.
Okay.
I've seen both. Yeah, usually more Snowflake is your thinking ideally, but
Right.
again, don't limit to that,
Yep.
because if you limit to that, only I have to demand develop Snowflake and all. Don't keep that in mind.
Got it.
It
Got it.
will
Just for
ask your, yeah, yeah, ask your product manager or product owner or whoever you are working upon. that what is my use case. Okay,
Okay.
so it depends on that. Because if you store unnecessarily more tables, more compute, more processing power, more jobs, right? The cost also increases, but you do not have an use case associated with that. Maybe if you might have in future, then well and good. Okay.
Okay.
So from that point of view, just give me a second. Connecting charger. Okay. Yeah. So the Snowflake and Snowflake is covered. Any questions on that? See, again,
No.
they have given the same kind of example. Your dimension is further split. Okay.
Hmm. Hmm.
And whereas in star schema, you just have simple thing.
Okay.
Okay. Okay. So for today, I think we should be good on this. Tomorrow, I'll show you like how these concepts were related to the SQL data model which I have.
Okay.
The and then we'll try to do some querying around it.
That's very important, which I am not really good at.
Yeah. Don't worry. Like also, mm, it like your that confidence would increase on your practice. Okay.
Okay.
So I'll give you some content where you will do some practice. Uh, but I'll teach you how first the concepts are, like what join needs to be used and how they internally work and something like that.
Okay.
Okay then. I think we should be good for today, right?
Okay. Yeah. Yeah. We're good. Okay. I'll stop the recording.
Yeah. Okay then. Thank you.
Thank you, Aditya. Bye.
Bye.